Banks. They represent the circulatory systems of our economies. In the same way the cardiovascular system distributes oxygen and nutrients needed by our cells, banks distribute financing from people that have a surplus of funds and want to invest towards productive projects built by people and companies that need financing. However, during the last decades, banks expanded their activities to include more complex financial transactions. Episodes of financial meltdowns are well known, with huge costs imposed on banks, on taxpayer and society. In the case of a system-wide breakdown, banks need huge amounts of government money to be bailed out. And in case they stop performing their intermediation function, then the whole economy gets blocked. Companies are not able to continue their operations, and people get laid off. Therefore, it is essential to ensure the continuous supervision of the banking system and ensure also the correct estimation of the risk involved in it. My research started as a curiosity about how to measure overall risk related to banks' activities in the context of an increasingly interconnected financial system. It seems natural to look at bank interactions from a graph perspective, where banks are seen as nodes and the activities they take part in with each other are seen as links. So I started studying the applications of network theory in finance and economics, but I soon realized that this approach to measuring risk is actually quite novel. Up to the financial crisis, there was little research done on the topic of bank networks, even though it was clear that there was a holistic perspective that was missing. The researchers, they were typically concerned with evaluating the risk for individual banks, so their behavior was analyzed in isolation. You would be concerned with how banks were attracting their funds, so the risk related to raising funds, and how they were using the funds, the investments they were offering. So this is actually not the whole picture and is not very realistic. Why? Because banks, like people, they interact with each other through multiple activities. For example, they can lend and borrow money from other banks through the interbank market. They can provide security, they can provide insurance contracts, and also invest in similar portfolios. So this creates a deeply interconnected financial system, where the action of one actor impacts and is affected by the actions of the other actors and the state of the system as a whole. Modeling interactions as networks is of course not unique to banking, and integrated, interconnected systems exist from the beginning of life. In biology and sociology, researchers already started to investigate various questions from networks perspective. For example, you can check the spread of disease or the flow and adoption of political ideas. Mostly, it all boils down to identifying the network structure and the role played by individual nodes in the transmission of information. Using a similar approach, we can also track the flow of risks in the banking system and check what are the conditions for the operation of tipping points and whether supervisory measures they have the expected effect. Intuitively, you would expect that the probability of a bank being in distress should increase if it has other neighbors that are already in distress. So one of my research projects tests precisely this idea. I analyze whether models that predict bank distress, for example, try to anticipate difficulties 2 years in advance, can be improved by taking into account possible contagion channels that banks have among them. So in order to test the usefulness of the interbank network, we have to have some specific information about how much banks are transacting with each other. And unfortunately, this type of information is not publicly available, at least not as detailed as we need it. So I started by guessing what are the possible links among different banks by looking at the likelihood of observing similar shocks to banks' stock prices in such a way that these extreme negative shocks represent crisis situations, so they are of interest for policymakers, and are also in excess of what can be explained by general economic conditions. So this allowed me to obtain a network where I was able to say whether any two banks, they are linked or not. However, I was not able to have any information about the source or the size of such links. In the case of the European banks, the estimated network would look like this. So we have a core periphery structure, where banks situated in the core are much more connected and have a more important role in the transmission and absorption of distress. Overall, the results for the prediction model, they were improved in two ways when taking into account contagion effects. We had better performance both in terms of missing fewer distress signals. This allows us to avoid financial failures. So the false negative rate of the model decreased when we introduced the contagion effects. And on the other hand, we were also able to give fewer false alarms. And this is important because this allows us to reduce the costs related with unnecessary interventions. So having fewer false alarms reduced the false positive rate in the prediction model. My next step in the research is to look at bank activities differently for each type of interactions they have. So the idea is to build a collection of network layers in which each activity represents one layer and they all cover the same banks. This would allow us to model the behavior behind each bank and allow the transmission of contagion in the network. In such a way, we would be able, of course, to better estimate and have a holistic perspective on the system inherent on the risk inherent in the system. Now, what else did I learn from my PhD? Well, being a researcher and living in a dynamic and continuously evolving world is challenging, and that's because we have to be part of new developments as well. And what this means is that we have to keep an open mind and also be ready to take interdisciplinary steps when searching for solutions. Thank you.